Good morning, good afternoon, and good evening. Hey, thanks for joining the webinar. As Lori stated, today we'll be discussing getting the most of your product design and manufacturing collection. I am Tom Coons, and I'm presented here with Mark Flayler, and we are both from IMAGINiT Technologies. This webinar should last approximately 45 minutes, and we'll make sure we have plenty of time for questions. As Lori stated, please feel free to use the chat feature as we progress throughout the dialogue, and we'll be continuing to monitor that as well. So let's go ahead and jump into the agenda for today's session. So what you'll see is I'm going to provide a brief overview of IMAGINiT Technologies, and you'll also hear the word RAND worldwide. We'll talk briefly about what is the PDM, Product Design Manufacturing Collection, educate you on each tool within the collection, and then we'll follow up with additional questions from that call. So on talking about RAND worldwide, what you'll notice is you'll see at the very top, IMAGINiT Technologies. We are an Autodesk Platinum provider. What you'll also identify is we also tie into technology from Leica and Epic. To give you an example, reality capture scanning in the factory, pulling point cloud data into Inventor, and you'll hear Mark talk about Inventor some more. In addition, Epic Games is great for creating rich digital visualization of a factory or facility that you may be constructing. We also have another organization called RAND Sim, and you'll see throughout Mark's presentation related to the product design and manufacturing collection that we have simulation capability in it. So we have a dedicated organization that can help improve your design features well before production. And another tool within simulation is discrete simulation around the factory to ensure optimal factory layout. So there's another tool called ProModel, which is a great fit for those laying out the factory in AutoCAD, which again is another tool within your collection. On the bottom of that chart, you'll see RAND 3D, another part of the organization that is really supports those customers that are multi-CAD. You may have other variations of CAD within your portfolio. We can help support and train in those situations also. And last but definitely not least, the bubble on the left side there is Ascent, and that's our dedicated organization for training, creating custom content, incorporating your standard operating procedures into our training platform or whatever training platform you have within your organization. So that's a good view of RAND worldwide. On the next chart, you'll see this is all the breadth of IMAGINiT, specifically the larger dots are our office locations as well as our employees. We're over 430 employees across the US, so we definitely have a good coverage model, and definitely we're looking forward to working with you. On the next slide, you will see this is just one last element I want to highlight. Is we strive to be your trusted advisor and strategic partner for all of our clients. And you can kind of walk yourself through this, but it really points out our services capabilities. So as you learn more about the product design manufacturing collection today and continue to leverage the power that Mark is about to present, definitely reach out to myself, anyone else on my team to discuss further enhancements that we can move beyond the tool set. So for example, we have several customers and case studies in which customers have automated their design and development using the tools like Inventor, AutoCAD Electrical, just to name just a few, taking some of those business rules that you are doing on a daily basis for your customers and incorporating that and accelerating your development, obviously driving a quicker return on investment for the products that you're designing and building throughout the value chain. So lastly, what is the product design and manufacturing collection? Again, as you may or may not know, it's a suite of tools that really covers, and you heard me use the term value chain, takes it from design into engineering, into manufacturing. It can go through that whole process from what you heard Autodesk primarily speak about design to make and everything in between. And Mark is going to walk you through each element of that collection. The next item is around licensing option. This webinar is not dedicated for how that product is actually licensed. but definitely give us a call, put your information in chat. I can definitely reach out to you at a future date to discuss that. So without further delay, I want to pass the mic over to Mark to dive deep into the product design and manufacturing collection. Thank you. Mark, go ahead.
All right, thanks, Tom. So let's go ahead and move on here next. What we're going to look at inside the product design manufacturing collection again today is kind of an overview of all the technologies that can work together or can enable you to do certain things. And around that are 4 primary principles. How can we spend more time innovating and less time with the minutia of work? How can we really automate and enable ourselves to innovate? How can we improve performance? So how are we trying to get throughput to the shop faster, or how are we trying to collaborate more effectively? How can we win more business? You know, as manufacturing keeps changing, we have to keep innovating faster and faster. We have to always have a market advantage. Sometimes that's time, sometimes that's design that we would have enabled by us for the product design manufacturing collection. And overall, how do we streamline all this manufacturing? How do we make things to market faster? So we're going to see quite a few of these kind of core principles have as outcomes throughout our presentation today. Now we're going to start with the hero product that is inside the product design and manufacturing collection, and that is Autodesk Inventor, which is a professional grade 3D modeler. It's been around for a very long time. It's a very mature product, and it's really at the core of the tool set for enablement around your design efforts. Now, Inventor Professional is really designed for mechanical design. That's why it's the product design and manufacturing collection's hero product. It does have a lot of specialized tool sets inside of it. To name a few: sheet metal, welded frames, tube and pipe. It also has things like injection molding, so you can actually build a mold and die rather quickly. It has more advanced surface capabilities as well for creating NURBS-based surfaces, and that's available through different modeling tools such as parametric, which most people know quite well, direct modeling, and the last one being freeform for that NURBS-based design. There's a lot of ways you can actually model inside of this. There's also a fair amount of design automation built in. Probably about 13 or 14 years ago, iLogic was added to the Inventor product. And this, it really enables innovation and configuration inside of your product rather effectively. So you can have a rules-based design that says, for instance, I have this conveyor. It has these rules to it. It can be certain lengths, it can be certain widths, it can be certain heights. If this changes, then this also has to change. Things that you would go through in the minutia of doing on a daily basis, but can be more automated. So putting yourself into a design intent sort of scenario, and you can actually have this preloaded with fields to fill out and forms to fill out. These can be shared up into the Autodesk environment for collaborative viewing and such as well. But in the end, it's going to really help make that minutia of the daily work much faster. So you no longer have to go to each individual part and say, extend this face 3 inches. Now go over here and extend that face 3 inches. Oh, now my constraints broke. Now I need to go fix those, right? This all kind of builds that design intent into your model so you can reach your market faster and get your quotes turned around faster as well. Inventor also has an extreme amount of interoperability or associativity to other file types. So starting a couple years ago, Inventor added this technology called AnyCAD. This allows you to bring in models from all these different sources, and they can either be converted, which is very traditional, right? We take, let's say, a CATIA file or an NX file, and we convert it into an Inventor file. That's something that's always been around. But this AnyCAD technology allows you to reference it in. So for instance, maybe I'm working with somebody that has a step file or a SolidWorks part or assembly, and they constantly keep sending me updates of this design. Well, in the past, you'd have to reconvert it every time. Nowadays, you can simply reference it in. So as you get a new version of that file, Inventor automatically recognizes that and says, there's a new version. I don't have to retranslate it. I don't have to put constraints back together. It just says this is the new version of the thing. So it allows you to skip translation. Very powerful. In that same vein is the ability to interoperate with Autodesk Revit, which is becoming much more common nowadays, especially with factory work or large-scale machinery implementations and integrations. So with this, you can actually reference a Revit model directly into Inventor, and then you can build your equipment around it. And likewise, you can save data out directly to Revit. I don't know of any other product in the market that does that. So you can create an RVT directly from an Inventor assembly for it to be consumed inside of those other products. You can also do things like authoring BIM objects, like Revit families. So very functional sort of interoperability here. This is a industry-leading exclusive kind of interoperability between these types of products. Now, Inventor does have a great way to share and collaborate as well. So there's something called shared views inside of Inventor that can really enable your collaboration to really, get the stakeholders buy-in without having to send large data sets. Okay, so for instance, I'm working on a very intricate design. If I had to pack it up, maybe it's a couple of gigs in size, right? I'd rather just share that with my external stakeholders and get their feedback right away. I don't want to wait to upload something to an FTP, then to download it and put it into a viewer, or to send some other sort of large file type around. So with Inventor, you can share a view, and this puts it up into the Autodesk 360 environment. It's password protected. And what can happen there is people can view and comment and measure and even mark things up. They can section it, they can explode it, they can examine what you're trying to portray to them for your product. It does expire in the 30-day time frame, but that can be extended. Ultimately, the greatest thing about this is you're not sharing your IP directly. You're basically just uploading a visualization that's highly functionable. So no models get uploaded, no risk of losing your intellectual property to somebody else. So Inventor is a very common product. A lot of people who are attending the session today know Inventor really well. It's been around, again, a very long time. It's a robust modeler, and the standard capabilities are pretty well known. Now, there is a lot of extended capabilities that will come in the product design and manufacturing collection. And these have been added over the years. Sometimes they get added and you didn't notice it, right? Sometimes they get added and they're just another thing that's in your portal, right? And you don't have time to really investigate what it's about. Well, that's why we're here today. So the first thing we'll talk about is Inventor tolerance analysis. This was added a couple years ago as well. We have the Autodesk factory design utilities. This has been around a lot longer, and it used to be a separate package. Now it's actually included in this one collection. There's also Inventor Nastran. We'll discuss that. Inventor CAM, and also Inventor nesting. So starting with tolerance analysis. This utilizes the Inventor model-based definition, or MBD. So a lot of people call this the way to create a drawing without creating a drawing. You can actually put your dimensions and your geometric dimensioning and tolerancing right inside of your 3D model. Now, the tolerance analysis will do linear stack-ups for 2D linear stack-ups. So you can actually look at how you can reduce tolerance issues. So you can also look at doing report generations and some more advanced statistical analysis results from this. So what's going to happen is it's going to give you results about, well, if I keep doing these things, it's going to keep increasing the cost, right? So how important is that tolerance? Helps you make those decisions faster. Factory design. So again, this is a great tool that used to be its own separate product, but is now included in the collection as well. And this allows you to plan and validate factory layouts for efficient equipment placement. So essentially, will it fit, right? So where's my safe zones? Where is my HVAC ducting? Is it going to fit inside of here? There are some industry exclusives here too. So there is a AutoCAD and Inventor synchronization. Inside of AutoCAD, you can place blocks, click a button, and say, here's the Inventor layout, and it automatically puts the 3D version of the asset in the same 2D location from the AutoCAD drawing. Likewise, if you start in Inventor and want to create 2D drawings, because a lot of people still work in 2D, over 95% of factory layouts are still done in 2D, you can synchronize your 3D factory layout to a 2D consumable or your 2D drawing package to share out and collaborate with. The Inventor Nastran was a little bit more recent of an acquisition by Autodesk. In the past, you would always have the ability to do a stress analysis inside of Inventor, but once you hit the yield point on a stress strain graph, you would go off into infinity, right? So it was designed for static loading. It wasn't designed for anything other than that. So with Nastran, this does not replace the standard Inventor FEA. When you put this in, you'll get another set of tools. You get another ribbon just for Nastran. It allows you to do nonlinear, fatigue, and thermal, more advanced vibration and dynamic analysis on your designs. And that can also be exported as well, but this gives you a deeper dive into your simulation funnel, right? So you can go beyond just static loading. You can actually say, what happens if something strikes this, or if I have a drop test, right? These are things you can do with Inventor Nastran. With the CAM capability that was added to Inventor, you can do 2.5 to 5 axis CAM milling, multi-axis operations, as well as adaptive clearing, turning, and mill turn. But really your value proposition here is around getting things to manufacturing faster. So if I were to design a part inside of Inventor, and I go into Inventor CAM, all inside of Inventor, mind you, I can do my G codes, I can do my tooling changes, I can do the simulation of it all, and then I can bring it right into a Haas machine or one of my machines that's capable for it. The added benefit here is you don't have to do a step out or a export out to another software. So if I make a change in my Inventor model, the G code and the updates to my CAM can automatically update, and I can get it to the shop faster. I can get it onto a machine, and I can go from part to part that much more efficiently. In that same vein is Inventor nesting. So nesting allows you to take sheet metal parts or anything that's been classified as a sheet metal part and allow you to lay it out into a nest. Once it's in a nest and it's been optimized for that nest, you can also generate cutting paths with Inventor CAM to send this right out to like a Mazak or a water jet type machine to do your cutting. Now, this used to be the Inventor, it used to be another add-in from Autodesk, sorry, not Inventor, it used to be TrueNest from Autodesk. So it's been incorporated into Inventor and allows you to do these sort of tasks. Again, if the model updates, your nesting can update, your G code can update. It's all very seamless in that sense. Now that we looked at the extended capabilities of Inventor, now let's look at the connected applications. What can connect into the software to enable better usage of certain tool sets, or to really harmonize our design a little bit more effectively, as well as help us collaborate better. Well, you do get AutoCAD in the Product Design Manufacturing Collection. And not only do you get AutoCAD, you get all of its cousins. So you get Map 3D, you get Mechanical, Electrical, and Plumbing, you get AutoCAD Architecture, you get Plant 3D, you get the vanilla AutoCAD, of course, you get AutoCAD Electrical, AutoCAD Mechanical, and you get Raster Design. So I'm going to speak about a few of these in a little bit, but I'm going to make a note of a few right now. So Raster Design, very nice software. If you have PDFs, you can bring those right into AutoCAD and you can vectorize them. You can take a coffee cup stained print that was scanned, bring it in, scrub out the coffee cup stain, re-vectorize it, and make it geometry that's modifiable. That's all included with the standard AutoCAD toolset there. Plant 3D is a little bit more geared for the petrochemical industries, maybe even health and beverage. So you can actually do large scale facility layouts as a 3D software for the most part. And you can also do P&IDs with that. So let's talk about some other ones. Autodesk Navisworks Manage, we'll discuss that one as well. Autodesk 3ds Max, typically a visualization software or a media and entertainment software. We'll see what kind of effect it has for our connected application. Autodesk ReCap Pro, and Autodesk Vault Basic. So these are the applications that connect themselves inside of this environment. There's a lot of interoperability that exists between these tools. Let's start with digging more into AutoCAD and Inventor. So with AutoCAD, you can actually take advantage of 2D and 3D workflows together. You can actually use existing 2D drawings to bring those into Inventor and create 3D parts from it. You know, basically putting your 2D AutoCAD drawing on two different planes and then creating extrusions from that geometry. There's actually some nice tools in there that can link that to existing AutoCAD geometry. If it were to change, they can update your Inventor model. There's some neat stuff there. You can also document your Inventor designs inside of AutoCAD. So you can actually go the other way, right? This requires AutoCAD or AutoCAD Mechanical to do that, but you can bring Inventor work inside of AutoCAD. If you are only using AutoCAD today and someone gives you an Inventor part, you can bring that in and document it. You can also do equipment layout for Plant 3D. That's sort of that interoperability too, right? So if I need to create a tank or a vessel or a pressure tank, that is, I can create it inside of Inventor to a high level of fabrication detail, and then directly save it out to a format that Plant 3D accepts, and actually accepts the pipe connections as well. It's called an ADSK export. And that's been in the software for some time. Navisworks is a model aggregator. Okay, so this tool allows us to bring in stakeholders from all walks of life, whether they be, you know, Revit type folks or people outside of our walls. But really, inside of our walls, we can bring in any pieces of data together and aggregate them into a complete set. This is important because if we have very large facilities, like if we're talking over 300 meters by 300 meters by 300 meters, with Inventor, you start getting some size limitation problems, right? When something gets so large. So if you bring it into Navisworks and you bring it in with a Revit model or civil site plan, all this stuff can be brought together and have a project collaboration around it. So it's designed for large scale design reviews. It does not create documentation in the traditional sense. It doesn't create 2D prints, right? It can create videos and walkthroughs and project plans. It can do clash detection, so you can actually bring in point clouds and see where that interacts with your existing layout. If you have a brownfield installation where you're putting something in, you can see what's going to collide with it. You can also do scheduling of installation. So if I have to come into an existing brownfield type build and I need to deconstruct some equipment to get my equipment in there, that needs to be part of the project plan. You can do a visual Gantt chart inside of this and then have people visually see what the process is going to be like, not just telling them or having a whiteboard that says what's going to take place. So everybody can be more involved in the collaboration of the project plan and the installation that's going to take place. Going a little bit further with AutoCAD and Inventor, there's also an electromechanical integration. So this has been around for a long time, but it got really good a couple years ago. So this allows you to actually do your schematics inside of AutoCAD Electrical. So your ladder diagrams, your push buttons you might put onto a ladder diagram, you know, single phase, three phase, all that good stuff. And then you can link it into Inventor to do your panel layouts. So I can actually get the routings for around these components. I need to go around these circuit breakers with my wired harness. I need to know what my DIN rail looks like, how thick it is, how much DIN rail I actually need. I also need to know how much wire I need to pull off the spool. So when you take things into Inventor, it takes into consideration all those things. You can get bills of material for wire lengths and DIN rail, which you can't get inside of AutoCAD Electrical. And these are bi-directional. So you can change things in Inventor and have them update your schematic or vice versa. It's a nice live link. When we look at Recap Pro, this takes that point cloud idea I mentioned a little bit in Navisworks a little bit further. So once you have a scan created, you can bring it into Recap and process it. You can do measurements in here. You can classify your data so it can be easier to turn on and off and to group together. And then this data can be brought and processed directly into Autodesk Inventor, into AutoCAD, or into Navisworks. And we'll get to a moment where, you know, that makes a lot of sense if we're doing factory, right? So factory design utilities has its tendrils into all these things. You know, factory design works with AutoCAD, Inventor, Navisworks. They all kind of work together. So if we can do that with a point cloud, it makes our life even better for understanding where existing equipment is or where proposed equipment needs to be installed. You can claim the point cloud, you can create points off of it, you can actually create planes, things of that nature inside of Inventor. So very powerful tool and allows you to really process that tool. Now, when we look at cinematic animations and renderings, this refers to 3ds Max. So this talks a little bit more about, you know, how we're going to sell this, how are we going to win more business, right? How are we going to portray our design to the market, to the world? So there's certain things you can do with Inventor Studio, but it's limited, right? It's not a visualization or media and entertainment software at its core, but 3ds Max is. People make video games with this. People make television commercials with 3ds Max. Your Inventor data can be brought directly in as a direct import. Materials can be transferred in with it directly as well, and then you can simply animate it. Maybe you've always asked yourself, well, I have this particulate in this design that goes through a filter. I'd love to visualize that. I'd love to show that to my client. You can do that with 3ds Max. You can't do that with Inventor. You can't show particulate, right? Or sparks like you see on that engine bay on the left-hand side. So this gives you a lot of enhanced visualization capabilities. And again, it's part of your connected applications. Lastly, in these connected applications, we'll talk about Vault Basic. So this is a data management tool that allows you to do check-in and check-out ownership. So you'll get visual indicators inside your software that Bob over there on the other side of the wall has this checked out. I don't need to go bother him. I can see it right there. Or maybe someone else in the building has another file in their ownership that they're working on. So I can visually see that inside the software. You're not stepping on each other's toes. You're not overwriting each other on some network location. This is all exposed inside your software. It also allows for duplicate name enforcement. I talked to a client last week that they were looking to load files into their vault, and they had 50,000 files. I did an examination of their files. I looked at their entire directory, and I found they had 5,000 files named rubber.ipt. And we had a very, interesting conversation about that. How are you gonna rectify this problem? Are those all the same file? Well, they end up being different versions of rubber for every product they had. So how do you avoid that in the first place? Well, Vault will prevent you from putting duplicates in. You can turn that on. Okay? It also has extremely fast data searching. So Vault will search AutoCAD title blocks, and it will also search text objects. So if I have a text object like a leader note or an engineering note, well, that's not going to be a title block property. That's something on the page or on the sheet. You can actually tell it to search that file content, and it'll look inside the AutoCAD file and find those text objects and return those results to you. And on Inventor, you can search iProperties, of course, any sort of custom property you're tracking or standard property. You can also create your own properties as well. So if I were to add some non-CAD file, because Vault is agnostic, you can add whatever file you want to it. Let's say I add in a TIFF image or a PDF, or I add in a JPEG, something from the shop floor, something from the field. I can assign my own properties to that so it's searchable. So I don't have to go hunting for it, or people can find it more effectively by assigning data exclusive to Vault for that. So ultimately, this is designed to free up the time that it will take to do data management and collaboration, even internally or even externally in some cases. Taking that a little bit further, Vault also has much better control for file maintenance. This in turn actually replaces the Inventor Design Assistant. So if anyone ever had to use Design Assistant, or if you're still using it today, my heart goes out to you. Design Assistant has not been touched since Vault came out for good reason. It allows you to rename and replace references, update properties, and it does it through the SQL database that Vault runs on. So it's very effective at going through and fixing the internal links of your files. With AutoCAD files, it does that for external references as well. It can fix those relationships. And again, if you want to just mass change a bunch of properties and have them pushed into the files, you don't have to open up every file and make the change. Vault will do that for you. every time you check a design in, or change a property, or do a replace or a rename, Vault will actually create new versions for you. So you can actually go back in time. Maybe your design looked better last Monday than it does today. So you can actually roll back to previous versions and look at what that looked like, right? You can actually visualize it and view it before you even roll back to it. Next, we're going to talk about some more connected workflows. Okay, so we talked about some connected applications, but this is a little bit more for inventors' connected workflows, really directed towards that. And what we're going to see here is how we can really enable some of these more streamlined processes in the manufacturing area, as well as collaboration. We're going to do that with Fusion 360. This is also included with every product design and manufacturing collection. You get Fusion 360 design. And along with that, you get Fusion Teams as another enablement of your collection. So what are some things we can do from Inventor? Well, starting around Inventor 23, I believe is when they added this, even got better in 24, you'll have a Fusion 360 tab inside of Inventor, where you can tell it to do generative design studies up in the cloud. You can do simulation, you can do manufacturing techniques, you can even do design. So if there's a tool in Inventor that's not up to par with what Fusion has for design, then you can send it up there, do your modeling, and then bring it back into Inventor. So the reason why that's important is Fusion has a slightly different modeling kernel than Inventor does, right? It's been built from the ground up, and it's been around for 10 years, right? So it's no slouch in the modeling department. It has more advanced NURBS-based design than Inventor does, even for swoopy or organic shapes, as I like to call them. So you can send design data up there and then bring it back down and consume that in your Inventor design and create some tooling around it. Okay, so for instance, I'm doing a plastic part and I need to send this up there. So I'll send it up, do the advanced modeling, bring it back down, and do my injection molding tooling around that. Okay. Now, what happens when we send data up there? All right, we'll get to some of those tools in just a moment, but what happens when we send data to Fusion 360? This is sometimes a cloudy conversation for a lot of our clients. Well, it basically goes up to Fusion Teams. Fusion Teams is the data management control mechanisms for Fusion 360. So you send a file up there, it goes to Fusion Team. It's there for administration and data management. Everybody has access to this. Every PDMC in Fusion 360 license holder. So even if you have a mix of stuff, maybe your core engineers have PDMC, but your manufacturing group has Fusion 360. They also have a Teams license. It's just part of it. If someone doesn't have either one of those license types, you can get a participant license for design collaborators. For instance, I am working with an external shop that's using a non-Autodesk product, and they're sending me new data all the time, and I want to consume that and control that data. I want to see the versions as I'm getting it. You can do that through Fusion Teams and then consume it into your Fusion design or into your Inventor design. But you just have to have an Autodesk ID, which is free, and then you can invite somebody. This uses the Fusion 360 Drive desktop connector. So once you have all this stuff installed, you'll have another drive that will show up in Windows, much like, let's say like a Dropbox or a Box.net type drive. Or if you're using Revit, you might have a Docs drive. Right? So Fusion 360 would show up here. It is accessible in modern web browsers and also available directly inside of Fusion 360 to visualize this stuff. So what are some things you can do in Fusion Teams? Okay, again, we're going to get to the cool CAD stuff in a moment, but what is some of this collaboration stuff that you speak of, Mark? Well, it's a native repository. I already mentioned that. That's how Fusion files get stored. They get put into a team hub. But it can also store Inventor files complete with your file relationships. So this brake rotor assembly, well, I put it up there, it knows that it has these drawings, it knows it has these parts inside of it, and it understands those relationships and allows for that to be shared externally. So people can do markups, like you see there on the right-hand side. I can do comments on this brake rotor, and those will appear live directly inside of Fusion Teams. You can store really anything you want in here too. There's not unlimited viewers, of course, but you can store whatever documents you want. If you want to store a PDF, you can view that. Word and Excel documents, you can store it and view that. images, store it and view that. If it's a PLC code, you're going to store it. You're not going to look at it, right? So you can put anything you want up there to manage the product that you're collaborating with. It does also have version control where you can create milestones. So I got a new design in from that third-party contractor I was working with, and I'm going to create a milestone that I received it and I consumed it. And then he's going to send me one next week. That's going to be another new milestone. Okay? This allows me to do all this collaborative review, markup, and commenting without having to use tools which don't enable great CAD utilization for collaboration, right? This is something that is just amazing in that sense, and it's part of your collection. Now let's talk about some of the cool design stuff, right? So generative design. Typically, when you think of generative design, or when someone mentions it to you, you start to think of, okay, taking my design up here in this upper image and turning it into this bird's nest on the right-hand side, right? You might say to yourself, that looks cool, but I'm not looking for cool, I'm looking for functional, right? And that might be more expensive than what my clients are willing to pay. Well, think of it a different way. Think about the human design on the bottom here. You know, this is a weight of 3 kilograms. It's got a safety factor of 2.7. You can actually run simulation with the generative design, and it has a certain cost to it. Well, if I go through a generative design study, I can tell it to use manufacturing techniques, like milling techniques, to generatively design this to reduce my weight, but also maintain my safety factor. So not turning things into a bird's nest, but making my actual design work more efficient and more effective, right? So you might get to a point at the end though, where, well, I'm really reducing the weight down to 2.2 kilograms. My safety factor is 2, that's still good, but all that extra machining that goes into it's just too expensive. So I'm going to choose like option 2 or option 3 instead. But it enables me to make those decisions without having to run costly prototypes or new G code all the time. So it allows me to do that as a digital prototype. There's also additive capabilities inside of Fusion 360. Now, maybe you're thinking 3D additive plastic printing, right? Well, yeah, I can do that, but it's not the best, right? Where this really shines is for metal processes, like metal sintering. So Autodesk has quite a few add-ins they put into this, like NetFab, that will do metal sintering and 3D additive manufacturing processes. And it can slice your model. So again, your model changes, your slice will automatically update. So you don't have to export that to another, separate software. Now, the CAM aspects of Fusion 360 is where we've seen a lot of traction. So the CAM aspects of Fusion 360 are actually better than the Inventor CAM capabilities. So if you send a file to Fusion to do CAM work, it's going to be very efficient, just like it would be inside of Inventor, right? But you have more capability here. You can actually add on additional machining extensions to make it even more effective for inspection and probing, as well as doing steep and shallow sort of cutting and milling operations. So the core Fusion 360 that you get, though, can do milling. It can do that. You don't have to buy an add-on. It does come with some milling and inspection capabilities. So, for instance, I'm doing a class at Autodesk University this year on manual inspections, first article inspections with Fusion 360, things that people have been asking for in Inventor for a long time. Why can't I create an inspection drawing? Well, you can today. You simply send it to Fusion, and then you create your first article manual inspection, and then you can do an inspection recording for quality control right inside of your core environments. There's also electronics. So this was a more recent add-in into Fusion 360. Autodesk purchased a company called Eagle, and they incorporated it fully into Fusion 360 to do PCB design. And you can take your PCB that you create in Fusion 360, you can run simulations on it for heat using an ANSYS plugin that's part of the software. And you can basically create your drawings inside of Inventor. You can visualize the circuit board right inside of Inventor, as you can see here in this image. So really allows that to come full circle. That's something that was always missing, I feel, from the electronics package that Autodesk had. And this really, brings it to completion. So I'm going to turn this back over to Tom for our conclusion and wrap up.
Outstanding. Thank you, Mark. So we are right on time. We got 5 minutes to spare before we open up to questions. Number one, just to wrap up, we provided an overview of IMAGINiT technologies. So again, feel free to reach out to any one of us or any of your account executives to give you deeper dive into any of the technology around Autodesk or even our RAND organization. We want to help you for what you're building today, what you're manufacturing today, as well as where you're trying to go. Ultimately, can we apply your technology to where you're seeing it today to where you want to go in the future? We can definitely help with that. So don't hesitate to reach out. Number two, you saw the detailed overview of the product design manufacturing collection. You can tell it has a ton of products inside of it, many of which you may not be aware of. Many of you may only be using one or two products of the collection, but there's so much more available there. Number three, apply the product design manufacturing collection on usage approaches and recommendations. So throughout Mark's presentation, he gave you a couple examples. So net, you saw Inventor, you saw the various flavors of AutoCAD, you saw iLogic being applied to Inventor, which helps on the automation. You heard us mention point clouds, bringing that in, simulation with Nastran and a variety of other capabilities there. In the collaboration space, you saw Vault and Vault Basic. Obviously, there's extensions above and beyond that. You saw Fusion Teams. Even BIM integrations between Inventor to BIM as well. And then the manufacturing side, nesting, factory layouts that we can do with AutoCAD, and then even doing some level of simulation and communication of how the factory is laid out, and as well as definitely not to mention CAM. So with all that said, there's a ton of products within that collection. We're going to go ahead and provide a wrap up. So Lori, can you please stop the recording?